Did you happen to have a chance to look over the slides or the video for last week's lecture on Thursday for dictionaries? Yeah. Okay, great.
I didn't watch the video, but
the slides. Okay. That's good. Yeah. As long as you can see the slides. But yeah, some basics, right? The data types for the keys and values, how to modifying a dictionary, and some dictionary methods that we use. Yeah, dot keys, dot values, dot items. Some other methods. Some exercises. And then also, dictionary membership. When you are trying to check if something is inside a dictionary, so here, like H rank is a dictionary with Finland as a key and 1 is a value. Denmark is a key, 2 is a value. Switzerland is a key, 3 is a value. When you check if Finland is in H rank is the name of the dictionary, that is true. When you check if something is in a dictionary, it'll only look at the keys, not the values. So when you try 2 in H rank, that will give you false. Because 2 is a value here in the dictionary, not a key. Okay. So then you can check to see Switzerland, is that an H rank? Yes, that is true. Because it has right here. Okay. Membership, word count. Okay, we'll get into word count right now. All right, 12:31. I'm going to go ahead and get started. Hello, everybody. Welcome back to another wonderful session of CSE 8A, Intro to Programming in Python. Today we're going to be covering a little bit more on dictionaries, just a little bit more. It's just going to be building off what we saw on Thursday. And then we're also going to start going into some data processing. Okay, data processing. This is what y'all are doing for your PA6. Okay, for PA6. This is going to be very, very, very beneficial for you for PA6 today. Okay? So, some announcements. PA6 is due on Wednesday. Okay, it's due on Wednesday. Make sure to do your PA6 as soon as possible. Just because I know you're also going to be studying for your final, which is on Friday. By the way, final exam is this Friday. The material will be cumulative, focusing on the second half of the class. More questions will be on the second half of the course rather than the first. Yeah?
Do you know what time the final is?
Yes, that should be listed on WebReg, but I think it's at 11:30 in the morning. 11:30 a.m. at the computer science basement where we have our labs. Yeah. Should be B260, I believe. But yeah, all that information should also be on WebReg, like where like the official listing of the final. Yeah, it'll be this Friday, 11:30 a.m. in the basement. Can you double check that for me, Chakwi? But I'm pretty sure it's that. I'm pretty sure, like 99% sure it's that. Okay. And then lastly, also course evaluations. Course evaluations for myself and for the team is due this Friday. I highly recommend y'all do this. It helps me out to see where I could better become a better instructor. Also, this is also like gonna help me with my job search, which I'm gonna be having this fall. So if you could please leave me an evaluation, a truthful evaluation. You don't have to leave a good one if you feel like I didn't do a good job. But if you did feel like I did a good job, then please go ahead and add that information to the course evaluation. That is due this Friday. I know that the exam is this Friday. If you want to wait until you finish your exam, that's fine too, right? But just please make sure to submit your course evaluations by this Friday, okay?
Yeah, the final is Friday, 11:30 to 2:30 p.m.
Friday, 11:30 to 2:30. If there are any accommodations that need to be done, we do have one makeup exam time, and that is from 4 to 7. Yeah, from 4 to 7 p.m. Okay. So if you need that accommodation, if you have like another final during the original final time, let us know so we can make that change. Okay. Cool. All right. So we're just going to review a couple of things from the last lecture. I was talking about it a little bit before as people were trickling in, but the allowed types in dictionaries. Okay, for dictionaries, any key that you have for a dictionary must be an immutable type. You cannot change it. So what are some key types that we could use? Tuples. Great. What else?
Floats.
Floats. Ints. Great. What else?
String.
Strings. Awesome. But what are some types that it cannot be? Any mutable types?
List.
A list. It cannot be a list. What else can it not be?
Dictionary.
A dictionary. It cannot be a dictionary. Okay? So this is very important because if you have a mutable type as a key, Python's going to get very mad at you. Okay? Now, what about values? For values, you can have any type you want. Name out some data types that we could put there. Ella, what is the data type that we can have as a value for dictionaries? A list. Great. What else? Int. Awesome.
Dictionary.
Dictionaries. Awesome.
Strings.
Strings. What about booleans? Can you put booleans in there?
Yeah.
Yes, because it is a data type. And any data type can be in the value for the dictionary. Okay? Now, how do we add things to dictionaries? How do we add things to dictionaries again? So let's assume we have a dictionary here. Right? Right, we have a dictionary. We have some stuff. And it goes to some other stuff. I'm going to put a list here. Right? Let's say I want to add a new thing to this dictionary. And let's say I want to add a key. Shout out a key. What key type do we want for this? Any key type. That is immutable.
Int.
An int. Sure. Tyler, give me an int.
5.
5. Awesome. We want to add 5 as a key. And now we want to put a value. What do we want to put for the value? Caesar, what type?
A list.
A list. Awesome. Ella, what should we have in that list? For the value. It can be anything we want.
Strings.
A list of strings. Awesome. I'm going to put one string as Ismael. And then another string is going to be Chao. Okay? We have this list of strings. And we have this key that we want to put for our dictionary. Our dictionary, we're going to call it my dict. My dictionary. How can we add this information to that dictionary?
Would it be 5? And then like colon. And then the list.
The list. Childhood. Right? So we have the 5, we have a colon, we have a list. Yes, that's the way that we would have it here if we were to just like hard code it in there. But what if we already had this dictionary and we're going to try to add this to this dictionary instead of hard coding it in there? What we want to do is like on a different line of code, add this information. How could we do that? Yes.
Right, my dict,
Mm-hmm.
and then in hard brackets add the new key 5, and
Like
set
that?
it equal to
Equal to.
the list.
Yes, that's exactly right. So what you do is you get the name of the dictionary. In this case, it's my dictionary, my dict, right? You put your hard brackets, and then you put whatever you want for your key, right? As long as it's an immutable type. In this case, we chose 5, right? So we're saying like at this, I want to add something, and we're adding this whole list, which is a list of strings. Ismail and Chakwe. Does that make sense? On how we add things? What if we wanted to delete something from the dictionary? Remove something. Let's say now, this right here was a string that was, I don't know, hello. And it was actually a list of integers, 5, 7, and 9. This is what we originally had for the dictionary. A key that said hello, and a list that said 5, 7, and 9. What if we want to delete this stuff? How can we delete that stuff from the dictionary on a new line of code? Any guesses?
Delete and then
Delete.
my dict and the key hello.
You put del, delete. Then you put my dict, my dictionary, and then hard bracket. Ah. Hello. Okay. That's how you remove something, delete something from a dictionary. Right? Now, I think we didn't really get to cover list of dictionaries, but let's look at what that may look like over here. All right, so we have, we'll get into that right now. So, let's say you have my dictionary, right? And then we had hello goes to 579, and we also have, oh sorry, we had like this, right? That's our dictionary. Print my dictionary. Run that, we can see the dictionary. Now, what we want to do is my dictionary at 5 is now going to be a string of Ismael and Chao Hui. Right? Now when we run that, we can see hello is 579, and then 5 goes to Ismael and Chao Hui. Right? And now if we wanted to delete my dictionary at hello, run that, we can see that now we only have that thing that we added. Right? What we can also do is have a list of dictionaries. We'll get into that a little bit later into this lecture. Okay? A little bit more into in the later this lecture. But before we do that, I'll delete all this. We're going to create a word counter. Okay? Yeah. Word counter. That was the answer. Forget that. Forget that the answer. Forget that you saw the answer. What we're going to do is make a word counter. And what the word counter is going to do is that give it a list of strings, right? Give it a list of strings. What we want to do is create a dictionary. And what that dictionary is going to do is going to count up every single time we saw one of these words. Okay? Every single time we saw one of these words. So this list, which is turkey, gravy, corn, cranberry, turkey, gravy, corn, turkey. Right? That's the list. We want to count them all up so that our dictionary ends up being like this. Turkey is 4, gravy is 2, corn is 3, cranberry is 1. Okay? Let's make a function. That's called a word counter. And we're going to say, we're going to pass in a list of words, our word list. Okay? How can we do this? Well, one of the first things that we want to do is have a dictionary, right? Something to show. So what I would do is put result is equal to an empty dictionary. We're going to start off with nothing, right? Let's assume we haven't seen any words yet. How can we go through the list of words and count them all up?
For loop.
A for loop. That's great. For, what do we want to go for? For what?
Dish.
Dish. In.
Word list.
Word list. Yeah. We can do for dish and word list. Let's do for word in word list, just because in this case it's dishes, but what if it was something else? Right? So let's just call it a word. A word in this word list. Right? So now you have your word. Right? How can I start to count up to see if I should add to my dictionary for a word list?
An if.
An if, okay. If, what do I want to check?
If your word is inside the dictionary.
If your word is in the dictionary, that we call result, what is this going to check when we do if word in result?
If the key exists inside of the dictionary.
If the key exists inside the dictionary, right? The keys that we want are unique words, right? So as we saw here, like turkey, gravy, corn, cranberry, all of those should be what we're looking for, right? So if you found that word in the result, what should we do? And so let's say you're like in this position of the list, right? You check to see, is turkey in the result? In this case, it should be, right? It should have a value of 2. Result at that word at turkey should be 2. So what should we do here? Now that I found it again, what should we do? Yep.
Result word plus equals 1. Or hard brackets.
Ah. Yes. Result word plus equals 1. We're just adding 1 to the word that we found, right? The word that we found in this case is turkey. We said we did find it in our results dictionary. And whatever it was before, when we get here, it should have been 2. Whatever it was before, I'm just going to add 1 to that because I saw it again. I'm counting up all my words. So now, result at that position word, or at that keyword, I'm going to add 1 to whatever it was before. Sound good? Awesome. Are we done? Maybe? What if we do this? Return result. Let's see what we get. So we're expecting that. So if we print word counter with our list of dishes, let's run that. Oh! We have an empty dictionary. Why is that?
There's nothing in your results.
There's nothing in the results. Well, aren't we adding stuff? Yeah? You think out loud? I love hearing people think out loud. Aren't we adding things? Why is this not working?
We're only adding things if the word is already in the key.
We're only adding stuff if word is already in result. So anytime we see any word, any new word, right? So when we first go into this word in word list, the first word we see is turkey. Is turkey currently in result? No. Because of that, we don't add nothing to the result. We don't add anything, and we just keep on going. Looping, looping, looping. Looking for something that never existed. So, what can we do? We know that when we find something that already exists there, we add 1 to it. But what if we find something that does not exist there? AKA, what else? What else can we do? If we find the key in the dictionary, that means we just have to add 1 to it. If you've never seen this word before, what should we do? Hint, hint. Maybe something like this? Maybe? What should we do? Angel, what do you think we should do? We could try stuff out. Anything.
Since you're going through the for loop,
Uh-huh.
I would assume that, let's see, result.
So in this case, right? If we're going one by one, we're doing the for loop for word and word list. First word we see is turkey. First one we see. Is turkey in the result currently? No. So because it's not there, we can't add 1 to it. So instead, we should do something else. We should probably add it to our dictionary, right? How do we do that?
Would it be result and then the brackets?
Yep.
Word.
Word, great.
And would it be then like a list?
A list, like this?
Yeah, but
Maybe not a list, right? We don't need a list here because we're not going to be like adding lists to our results of words. Remember, what we were looking for at the very end is something like this. Integers. So, if I've never seen this word before at all, and then I see it for the first time, I can say that the results, our dictionary results, at that word, in this case turkey, right, is now equal to a certain number. AKA, I've seen it for the first time.
position 0.
1. We're not looking at positions right now. What we're doing here is just counting up the amount of words that we've seen so far. What we're doing here now is we look at Turkey for the first time. We're at 4 words in the word list. We see this is the first word we have, Turkey. Is Turkey in the result at the very beginning? No. So that means we go into this else statement instead. And now what we're saying is our dictionary results for Turkey, I'm going to say I've seen it one time at least now. I have seen it now. Once. And now the next time you see Turkey, let's say you go Turkey, gravy, corn, cranberry, now you're seeing Turkey again.
It's going to add.
Now it's going to add 1 because Turkey now exists inside of my dictionary. So I could keep on adding 1. So now when we run this, run it, we have Turkey 4, gravy 2, corn 3, cranberry 1. Does this make sense as to how this word counter is working? Awesome. Okay. All right. Cool. So now that was our word counter. What we do is we check to see if something is inside of our dictionary keys. If it's there, we just add 1. And if it's not, we make it 1. Because that's what we've counted so far. If it's not in the dictionary, we have to add 1 to it immediately. Otherwise, we just add 1 to what was already pre-existing there. Okay? So, what we're going to be doing now is data processing. Okay? Data processing. This is what's going to be very, very, very important to do for PA6, which is already out, and due this Wednesday. All right? What we're going to be doing is looking at 2D data as comma-separated values. This is a file type. So like .txt is a text file, .py is a Python file, .pdf is a PDF file. There's a thing called .csv, which is a CSV file, a comma-separated values file. Okay? We're going to see what that looks like. And then we're going to access data in that CSV file as a list of dictionaries or a nested dictionary. Basically a dictionary of dictionaries. Okay? So, why are we doing this? So, data itself, when we do data processing, can really help us highlight certain biases that exist out in the real world, right? Getting real world data, analyzing it, and then showing some sort of bias that exists outside in the world, right? Using actual data. It's a very powerful tool to highlight these facts and biases. So in the US, Latin Americans, Latinos make up 19% of the population. That's the second largest ethnic group in the US, only behind white and Caucasian, right? They're the second largest at 19% of the whole United States. In California, Latinos make up 39% of the population. So Latin Americans are actually the largest ethnic group in California. What does this look like in computer science, right? We would assume that maybe they're like at around 19% of computer scientists in the United States because they are 19% of the population. You would hope that it's like around there. It doesn't have to be that exactly. It could be a bit lower, it could be a bit higher. It's like around that ballpark range, we would assume. But using data, we can see that Hispanics of any race, they label it as Hispanic. They're at 9.34%. 9.34%. Lower than half of the US population. Those are the bachelor's degrees that get awarded by ethnicity in the United States. 9.34%. Okay? So massive sort of underrepresentation. And what we're going to be able to do is actually use data that UCSD has, use data that the UC system-wide has, so we can see what does this look like at the UC system, at UCSD specifically. We can check to see this sort of information. Okay? So in order to do that, what we need to do is read in data using something called a CSV file. Okay? Comma-separated values. A comma-separated value file is exactly what it sounds like. It's information that is separated by commas. Okay? So this is a random CSV file that I created. today, where I have a name, comma, a grade level, comma, the position, comma, and their favorite food. AKA, my name is Ismael Molina, comma, I am a 5th year PhD student, comma, I am the instructor in this class, comma, and my favorite food is tamales. I can do the same thing for Anshul Shah, who's the other instructor. Anshul Shah, also a 5th year PhD student, also the instructor. His favorite is biryani. Audrey Montalvo, 2nd year PhD student, a TA here for this class, and she loves saltado. Lomo saltado. Chao Hui Lee, the back, 2nd year PhD student, a TA, and loves spicy hot. Okay? If I were to add Kevin to this CSV file, the way that I would do it is as follows. I have Kevin with a Y, right? Kevin, okay? I'll change the colors right now. You are a, let me check that. Okay, you are, what are you?
First year masters.
First year master's student, tutor, and what's your favorite food?
I'll just say burritos.
Burritos. Awesome. So now, Kevin here, if I'm adding them to the CSV file, would look like that. Kevin is the name, right? Because it is lined up here with the name. Kevin is a 1st year master's student. Right? Make that purple. Kevin is a tutor. Make that green. And Kevin likes burritos. Right? This is what a CSV file is. Let's look at what that CSV file looks like for what I was saying before. For like this representation stuff. Go here. In your EdStem, right, for PA6 and also for this lesson 17 that you could open up on your machine right now if you'd like. We now have the CSE 8A CSV file, right, which has all the different functions for reading in a CSV file. Should we edit CSE 8A CSV file? No! Do not edit CSE 8A CSV file, okay? This is a Python file that will go in and read CSV files for you. You don't have to get into the reason why all of this works, but basically we did a whole bunch of information to make sure that you get the information that you need from our data sets. Some of those data sets look like this. UCSD all demographics, or UCSD CSE demographics. Let's look at CSE demographics, Computer Science and Engineering Department. Okay? This is a CSV file where we have the level of where they're at, so undergraduate or graduate students. We have their ethnicity, international, domestic unknown, white, Asian, Native Hawaiian, Pacific Islander. The year of where this data is taking place. So this, like, for undergraduate student, Latino students in 2023 at UCSD Computer Science and Engineering, there was a total of how many students? 231 students, okay, for 2023 in Computer Science and Engineering at UCSD, right? That is data that we can see and work with. So what about this line right here? What is this telling us in the CSV file? Yes.
In 2015, there were 25 African American undergraduates.
At UCSD, Computer Science and Engineering. Yes. And the reason why we say at UCSD CSE is because that's the name of our file. We know that that's what this file is giving us. Okay? So, that's exactly right. And how can we read this information in? Well, we can do that for you with these nifty, with these nifty little functions that we created for you. Get UCSD data. So now, when I print UCSD CSE data, right? When I print this out, run, what I get is a whole bunch of data, right? Where it's a list, right? We have a list now We have a list of, what are these?
Dictionaries.
Dictionaries. We have a list of dictionaries now, where each row, right, each element in our list is one of the rows of the CSV file, right? It's one of these. But it's separated in a dictionary where the key is this top row, level, or ethnicity, or year, or students. And then the value will be the actual information here. For this row, the value for level is undergraduate. The value for ethnicity key is African American. The value for the year key is 2023, and the value for the students key is 43. Does that make sense as to what's going on here? Yes, no, yes, no? Anyone confused about this list of dictionaries so far? Yes, no, yes, no? We now have a list of dictionaries with this CSV file. Okay? A list of dictionaries with that CSV. Any questions about what CSV files are and how they work? Yes?
What if your data has like commas in it?
What if your data has commas in it? That's a great question, right? If you know that your data is going to have commas in it, we suggest switching from a CSV file to a TSV file, which is instead of comma separated values, those would be tab separated values. So you use the tab key. So if we were to make this instead of commas, we'd have to go like this, a tab. Tab and tab. Okay? That way, if you know you're going to have commas in your data, instead of using comma separated values, it's best to do tab separated values. That make sense? Yeah. Okay. Thank you for the question. Any other questions on CSVs? Huh? Great. Cool. So, before we get into the actual data processing itself, how many columns are in the data in the CSV file below? How many columns? Six? Which are the six?
City, state,
City, state.
Monday, Tuesday, Wednesday, Thursday, and Friday.
City, state, Monday, Tuesday, Wednesday, Thursday, Friday. 6. Okay? 6. How about now? How many columns are in the data for the file below?
7.
7. Now it's city, comma, state. So now I have city, state, Monday, Tuesday, Wednesday, Thursday, Friday. 7. Okay? Awesome. So now, accessing CSVs using a list of dictionaries. We now have our list of dictionaries here, right? We have a list of dictionaries. With we're printing out here UCSD CSE data. If we want to just print out each one of the dictionaries, what can we do? Just print it out. Each dictionary in the list of dictionaries. A for loop, great. For, let's call it like maybe row data, right? Or a data row. For data row in UCSD CSE data. Okay. What will data row be giving us? A dictionary, right? A dictionary with some sort of information, and that information is listed here, like this. It'll give us this row, where in 2023, there were 235 white undergraduate students at UCSD CSE, right? That's what it's going to give us. So let's just print data row, and let's just break right away. So we just get the first thing, just so we can see what it looks like. Run that. We can see here that for undergraduate students, ethnicity is international. I don't love the way that they have the ethnicity is international because international students could be of various different ethnicities, right? But that's the data that we're working with. This is the data that they gave us, right? That exists outside, like out there in the world for us to download and find, right? That's the way that they presented it for us. So ethnicity is international. In the year 2023, there were 454 students. 454 students. 454 international undergraduate students in the UCSD CSE for the year 2023. Okay? Now, we now can access our data. Looking back at what we had here in our slides, right? For example, underrepresentation of Latin American students in computer science in general. Do you think that UCSD is doing a better job or a worse job of 9.34%?
Better.
A better job? Let's find out using data processing. Okay? We are about to find out. We're going to uncover this whole thing, right, in UCSD grounds. Okay? Let's find out. So, what we want to do is get a percentage of Latin American students at UCSD Computer Science and Engineering. Okay? UCSD Computer Science and Engineering. How can we do that? We're now going through all our data, and each row of data will tell us whether they're undergraduates or graduate students, whether they are, sorry, what? What were they again? Their ethnicity, right? It says the level of where they're at, the ethnicity of that data, the year of where that data is taking place, and then how many students exist for that row. Okay? So just for the purposes of clarity, what we're going to be looking for is we will calculate all, let's do graduate students first, all Latina graduate representation across all years. So we're just going to take all years into account, any year, okay, and we're going to average it all out for all for the students. Is this making sense of what we're doing so far? What we're looking for? So, in theory, before we code anything, what's the process of us to get this information? What should we do? Let's assume we're not going to program anything at all. If we wanted to get this number, calculating all Latin graduate representation across all years for UCSD CSE, yes, what should we do?
We have to know the average.
We need to know the average. How do we get that average?
We have to add all of them together and then divide by how many there are.
Right? We have to add all of a certain number together and divide by another certain number. What's our top number that we're going to have? Graduate students? All graduate students or specific?
Just CSE graduate.
CSE graduate students. Okay. CSE grad students. Is it for all ethnicities or just Latin American students? For the top number.
Oh, for the top number? Yeah,
For an average.
Are you going to add every Latin graduate student and then divide by all of the graduate students? Right?
All the graduate students, yes. So the top number is going to be the number of Latin grad students, right? And the bottom number is the number of total graduate students. Okay? That's what we want to find. So that's our goal. How can we do that with this data? Another for loop? I'm not sure if we need another for loop, because if we have another for loop, what we're going to be doing is going through each one. I mean, I guess we could have another for loop. We could, in theory, have another for loop. But if we have another for loop, what we're going to be doing is going through all the keys in the dictionary to look for certain information. But the beauty of dictionaries, I love dictionaries. The beauty of dictionaries is that you don't really have to loop through a whole dictionary to find a certain value. You can access that certain value immediately by just calling its key, calling its level, its ethnicity, its year, and its students. Okay? So, one of the things that we can do, well, first, the thing that we need to do is have both of these numbers. They need to exist at some point. So before we even get into the for loop, what I'm going to have is Latin grad students. I'm going to make that 0. And I'm going to have total grad students. I'm also going to make that 0. I'm just going to counter. These are my counters. They want to count up how many times I see certain Latin students, Latin grad students, and how many times I see total grad students. Just a counter. And now we're going to go through all the data. Okay? Every single line of data. But in order to add to Latin grad students or to add to total grad students, we need to check if certain things are true. When will we add to total grad students?
Only for CSE, you find that it's only for CSE students.
It's only for CSE students? So for the data that we have here, all of them are CSE students now. We don't have to worry about their major. We know that they're in the department for computer science and engineering. A good guess. You have to look for something. Check if something's right.
You
Yeah?
always add to it.
Always add to it? Sorry?
You always add to the total grad students.
Always add to total grad students. So total grad students plus equals. What should we add? Let's look at the data
amount
again.
of students.
The amount of students.
So the last value.
The last value. Students. How can we access the students?
Data rows, hard bracket students.
Data row, hard bracket, students. Okay? Data row, hard bracket, students. Great. That is how we get our number of students. Let's just print it out to see what we're getting so far. Print total grad students across all the data. Oh wait, actually we can do that then. Across all the data, we have 30,782 grad students. That seems like a lot of students, right? In fact, I think it's too many students. The way that we have it right now, every single row we go into, we will add the amount of students, right? This row, also this row, also that row, also that row. Should we add every single row into total grad students? No. Why not?
Because we only want the graduate students, and the list also contains undergraduate.
Yes. Right now, our data has undergraduate students and it has graduate students. For the purposes of our question, for Latin American grad students, what we want is a total amount of grad students. So this is right? Like we do want to have this line of code somewhere, but we only want to add the students if something were true. What should we do?
If statement.
An if statement. And what are we going to try and check?
If data row level
If the data row at the level, right?
equals graduate.
Graduate. Okay. What this is doing now is it goes through every single line, right? This line, this line, this line, all the lines, and it checks to see the level. What is the level? What's the level in this row?
Undergraduate.
What's the level in this row?
Undergraduate.
Ella, what's the level in this row? Graduate. Angel, what's the level in this row?
Graduate.
Graduate, right? So we only want to add if we're seeing graduate. Now that we know that we are looking at graduate students, now we can add this. Because it doesn't matter what their ethnicity is, it doesn't matter what year it is, none of that other stuff. We know now that we're looking at grad students, and that's what we're interested in. Total grad students is now, we're going to add to that, right? So before, our number used to be 30,782. Now when we run it, oh, now it's 7,996. Much lower, right? But this is now the accurate number that we're looking for. Does that make sense so far? Great. Now we have our bottom number. Number of total graduate students. Great. How can we now get our number of Latin American graduate students?
Another if statement.
Another if statement? Where should I put it? Inside this if statement? Outside?
Yeah, and then,
Inside like this?
oh no, outside.
Outside?
Yeah.
Okay. Do you want an if statement or an elif statement?
Well, they could be, because if it's an else if statement, then it won't run if it's once it reaches
Right.
reads the data, the first line.
Right, the first line of graduate students. So you know for a fact you're looking for graduate students, right? So that means that anytime you have any sort of code inside of this if statement, you are guaranteed that you're looking at graduate students. They might be from a certain year, they might be of a certain ethnicity, but you know they are a graduate student, which is what we also want. We want to make sure that they're graduate students. So what we can do is, yes, have an if statement, but inside of that if statement. Do we know why? Caesar, why would we put this if statement inside?
Because in order for it to get to the second if statement, it has to complete the first
Yeah.
statement.
The only time you ever get to this if statement is if this if statement is true. We're looking for graduate students who are Latin American, right? Two different conditions. Two different conditions. So now so now we know that they're a graduate student. Now we have to check for something else. What else do we have to check for? If they're Latin American or not, their ethnicity. So if theta rho at, what is the key that we're looking for here? Ethnicity, right? If theta rho at ethnicity is equal to a certain value, the value that they have for this data set is Hispanic, Latino, open parentheses, A, close parentheses. Hispanic, Latino, Latina, okay? I have thoughts as to why they do that, but we won't get into that. That's a whole other discussion into other things, but that's okay. So now, with this if statement, what we're doing is, we're looking at every single row, right, in our for loop. If they're a graduate student, we go in here and we add total graduate students, we add the amount of students. And then we check to see, now in that same row of where we added the total grad students, we're checking to see if their ethnicity is Hispanic, Latino, Latina. Now what should we do?
Latin grad students plus equals data row, and then the students.
Students, yes. Now what you're doing is, when you're in here, right? When you go into this first if statement, everything in here means that they're going to be a grad student. And now when you check this data row, if ethnicity is Hispanic Latino, you check to see Latin grad students. Now you know that you're looking at Latin American grad students. And you're adding the amount of students to that Latin grad students. So now, are we done? No. Tyler, what should we do?
Inside your print statement,
Here?
yeah. Yeah, right there.
Yep. What should I do?
You should write, let's see, grad students and then divided by total grad students.
Latin grad students divided by our total grad students. Ta-da! It's this! Exactly what we were looking for. This is what we're calculating. Okay? So we'll run that. Now we can see 0.022, that seems a little too low. Oh, what we're getting here is like the percentage before moving the decimal spot. So what we can do is 100 times the Latin grad students divided by total grad students. This will give us the percentage number, okay? So we all said that UCSD is probably doing better than 9.34%. We're probably doing better than 9.34%. Let's see, using data processing, if that's true. We run it. Oh no! 2.26%. Is that higher or lower than our 9%? Lower. How much lower? Probably much lower than we expected, right? Much lower. So here we can see, using data, right, that not only are Latin American students underrepresented in computer science as a whole, but within computer science at UCSD, Latin American students are also very underrepresented. Okay? But I may have misled you just a little bit, because what we're looking at here is graduate students, right?
Yep.
But what the data that we're showing you here, that's bachelor's degrees. Bachelor's degrees awarded. Always be wary of the data that you're looking at and the data that you're comparing, okay? So now, we have this number, right? Latin grad students and total grad students. What if we wanted to change this to, instead of being graduate students, to be undergraduate students? Undergraduate students. What can we do now?
We change the first if statement to filter for undergraduate.
Undergraduate. Okay. Should we do anything else?
You could also change the variables.
Yes. I would do that. I would absolutely change the variable names to be like more. Let's actually do that right now, actually. So first we have this, right? Our graduate students, all that. Let's copy this over and paste that here now. We're now, instead of Latin grad students, let's do Latin U grad students. Total U grad students, total U grad students, Latin U grad students, Latin U grad students, and total U grad students. Okay. Oh yeah, and we said this, undergraduate. Right? I'm gonna comment this out for now, because that's for graduate representation. Let's look at undergraduate representation over the years. 10 years at UCSD, computer science and engineering. Are we close to that 9.34% for Latin American undergraduate students in computer science and engineering? 7.522%. Not quite the 9%, right, of all computer science in the United States. Not super far off. Not super far off, right? But still, we are even lower than the average of computer science as a whole in the United States, which is already lower than the average of the population of Latin Americans in the United States, right? This number should be around 19%, and we're actually down to 7, okay? So using this data, we can actually see underrepresentation issues using data processing. Does everyone understand how we got to this spot? Like how we got to calculate this information? Yes, no, yes, no? Yes? Okay, great. So, now we did that. What if I wanted to do a different ethnicity? Right? I'd have to keep on checking, like changing this value every single time, right? Kind of annoying, but I guess whatever. If instead of me going in and changing this hard-coded value every single time, what can I do instead? If I wanted to run this exact piece of code over and over and over again, But for different ethnicities, what can I make instead?
Function.
A function. Let's make a function. F. Check. Representation. Let's do grad students. Grads. We can have an ethnicity here. All we want to pass in is some sort of ethnicity, right? So it could be anything. So I'll put ethnic grad students is 0. Total grad students is 0. Right? All that same stuff for data. Oh wait, we also need to pass in our data. Whoops. My data. All right, we need some sort of data and we need some sort of ethnicity. So data row in my data. If, I mean, I could just copy and paste all this stuff, huh? Yeah, copy paste all that. There we go. Okay. So now we have my data, we have our ethnic grad students and our total grad students. For data row in my data, which is this. Data row level undergraduate. We want to check graduate students, graduates. Right? If they're graduate students, we add that, right? Instead of total U grad students, now this is total grad students. Right? Then if data row ethnicity is equal to, what should I put here now? Ethnicity, right? Something that we're passing in. Instead of Latin U grad students, we can do ethnic grad students. And now we can return ethnic grad students divided by total grad students, right? So now, instead of having to do it every single time, actually 100 times. Oops. Instead of having to do it every single time, over and over and over again, I now have a function that'll do it for me. Okay? So now what I can call is check representation. The data that we have is UCSD, CSE, data. And then what ethnicity do we want? We can also check for any ethnicity. Let's do Native Hawaiian Pacific Islander. Oh man, I see a 0 right there for students. Not looking good for UCSD right now. Let's see a 1 there. Not looking great, right? So what we can do is run that. Native Hawaiian Pacific Islander students. Check representation for graduate students. Run that. Ooh, we already multiplied by 100. For Native Hawaiian or Pacific Islander students at UCSD CSE, we get a total of 0.11% of students being Native Hawaiian or Pacific Islander students. Okay? And we could check that number across other data points. So if we go to the US Census, which is where I got all this other information, right? So all this other information that I got, I went to the US Census to look for something to compare it to. We could do the same thing for Pacific Islanders and things like that to compare our number that we got of 0.11 versus, whatever the actual representation is. We can do other things here, right? We can now check for Asian, for example. Asian. Much higher, at 12%, right? Seems a little low, right? From what we've seen at UCSD, but again, I have a gripe with the way that UCSD does it, because in reality, the main number that we have here is actually international. Which, what ethnicity is international? I don't know, right? It could be anything. It could be Latin American, right? From Argentina, from Brazil. Or it could be Asian, right? From China. Or from Korea. It could be African, right? It could be African from Somalia or the Congo. We don't know, right? Which is unfortunate. But we know for a fact that 69.38% of UCSD CSE graduate students are international students. Isn't that wild? Dang, that's crazy. Okay? So all of this is using data processing. Okay? Question?
No, don't international students pay full tuition?
I believe so. Yeah, I believe so. They may pay for full tuition. For graduate school, I believe it's different because as a graduate student, you're working for the university, you're working with like a professor, and you get paid as a TA, you get paid as a researcher, all that sort of thing. So for graduate students, it is a bit different. So some may pay some tuition fees, things like that. I'm not sure, but that's a possibility, right? So this is for graduate students. We can do the same thing for undergraduate students, right? So, jeez, so annoying. So what we can do is check representation. Instead of grads, we could do, U grads, right? U grads. U grad, undergraduate, right? U grad, and U grad, and U grad, right? And now what we can do is something similar, but instead of checking for graduate students, we can check for undergraduate students. International student population in the CSE UCSD, international students is actually at 19%. Okay? Much higher graduate student population than undergraduate student population. Okay? So like for international students that are at UCSD CSE, they may pay full tuition, right, at 19%, but it'd be for those 19% of students, not for the 69.38% students. Okay? Great, thank you for the question. Any other questions about this data processing? Yes, no, yes, no? This is all for CSE, but thankfully, because we have our functions now, and because UCSD CSE data is formatted in a similar way as UCSD all data, we can do this, all. So for the international student population at all of UCSD, international grad students are 39%, much lower than the computer science department. So it seems like the computer science department is specifically hiring more international grad students in their department compared to other departments at UCSD. Okay? And then 16% is kind of similar to that. What was the other percentage? Like 19%? Something like that. So undergraduate student population, kind of the same for international students in the CSE department compared to the full university. Okay? That's how you can do some data processing. You can ask questions and answer them yourself. Right? Does that make sense? Cool. Any questions so far on any of this stuff? Yes, no, yes, no? Alrighty then. So, we have 17 minutes left. Let's see. Now we can go through a couple of these questions. We can look at some of these questions, right? But also I'd like to open it up for all of y'all to see what you all want to see. Okay? So UCSD CSE, you have UC CSE, UC all, and UCSD all demographics. Okay? What kind of questions would y'all like to ask in terms of this data? Anything at all, and we can try and code it up. We can look for, like, we don't have to do like percentages or even. We could if we want to, we don't have to. We could look for specific demographics. We could look at a specific year maybe. We could look at a range of years, yeah, sure.
Maybe like change over years.
Change over years, okay? So for the change over years, what do we want to do? Like, what do we want to show when we do the change over years?
Maybe
For-
like
Yeah.
plug in 2 years, and then it tells you like the increase or decrease in the percentage of ethnicity.
2 different years, right? Then you want to see difference in enrollment numbers, right? Higher or lower. What else did you say?
By enrollment number is really like the percentage.
The percentage, okay, percentage. What do we want to get the percentage of?
Like the number of like a particular ethnicity.
Sure. We don't have to, but we can, right? So we can look for ethnicity. Difference in enrollment numbers, or instead of numbers, we'll do percentages, right? Percentages for specific ethnicity. Okay? That is what we're going to look for. Great. Let's try it out. Do you want to do it for UCSD all or just the computer science department? Actually, it doesn't matter. We'll make a function that can read either one of those two. Okay? Let's try it out. So first thing we need to do is make a function. And we're going to say check enrollment rates by years. Let's just name that as our function. What do we want to pass into our function?
Data set.
The data itself. So I'm going to call it my data. What else?
The years.
The years. So year 1 and year 2. What else?
Ethnicity.
And ethnicity. Anything else? I think that's it, right? Okay. So now we have all this information. We have the data that we want. We have the years that we're looking at. And we have a certain ethnicity to compare to. So what are we doing now? What we want to do is check for enrollment rates for a specific ethnicity for a given year. So, correct me if I'm wrong, Tyler, of what you were looking for. So we can just find out exactly what we want to program. The way that I see this happening is year 1 has certain numbers and year 2 has certain numbers. So we would get the number of a certain ethnicity of students over the total number of students for that year only. We're not looking at any other year, just that year. And we're going to do the same thing. I'm going to put number of E over number of T, number total. Is this what you were looking for? And then we could probably get like a difference. So just like this minus that. So we can see like whether there was an increase or decrease in terms of percentages. That's like, it sounds like a great idea. Okay? So, what kind of information should we keep track of? So before, what we were keeping track of is ethnic undergraduate students and then total undergraduate students, right, to do our math operation. Yes?
I think you could probably modify one of the earlier functions to make it easier to find the percentages for each year.
Sure. Let's do that. Copy that over here. What should we check? What should we change now?
The variable name.
Variable names. So what variable name do we want here?
Year 1 instance.
Year 1 ethnic students. And then? So that's getting this one, right? Just this one. What else do we need?
Year 1 total.
Yeah, year 1 total students. We done or do we need more stuff?
Also for
Also for what?
year 2.
Year 2. Ethnic students. And then year 2 total students. Awesome. Now we have that information. So now we're going to keep track of this number, and this number, and this number. Do we need to keep track of any other numbers? Or are we good? I think that's it. I think we're good, right? So now we're going to do for data row in my data. Should we change that at all? No, we still have to look at all the data rows, right? Then, if data row level is undergraduate, do we care whether they're undergraduate or graduate students with this given question? No, not really. So we don't have to check for that. What should we check for?
The year.
The year. So if data row at year is equal to a certain number, year one. First we're going to check for year one. If it is, what should we add to that?
Year one total, and the rest can stay the same.
So now, year one total students, right? The total amount of students in year one, just in general, regardless of ethnicity, will be in here, year one, data row, students. That makes sense. Awesome. Then, we check to see if at that data row, so we know that we're at the right year for year one. If at that data row, the ethnicity is what we were looking for, should we change any of this so far? No. Then we have to add something to this. What should we add here? Instead of ethnic U-grad students, we need to add something else to here.
Year one ethnic students.
Year one, yes, year one ethnic students. Does that make sense of why we did all this? Great. Are we done? No. What should we also do now?
Change the ethnic U-grad to year one.
This stuff?
Yeah.
We could do that. We could change it. Let's not change this one just yet. Because this number, right, what we're going to return is going to be the difference between this information and this information. So overall, we have this information so far. Let me just remove all that for now, just to return. Are we done? No. We still need to calculate stuff, right? Are we done for loop? No. What should we check, Tyler?
You need to check for year two.
Check for year two. How do I do that?
Go back to index, and then else if data row year equals year two.
Perfect. Why didn't I just put an else?
Because it also check both.
This is checking for year one specifically and year two specifically. If I put an else, I would be getting all other years that are not year one. So we need to check for year two. Great. So now what do we put in here?
Year two total students.
We're going to have all of this basically, all that same sort of calculation in here now. But instead of year one, now we're doing year two. Instead of year one, we're doing year two. Okay? Does that make sense so far? Of why we're doing this? Great. Are we done now? No. What should we do now? Get the averages and the difference? So we do year one average is equal to what?
Year one total students.
Total students?
Ethnic students.
Ethnic students first, right? Ethnic students will go on top. Year one ethnic students. Divided by year one total students. Great. Then, are we done?
No.
What else should we do?
Year two.
Year two average will be the same. Year two ethnic students divided by year two total students. Are we done now? No. What should we do?
Calculate the difference.
Calculate the difference. My difference is equal to year one average minus year two average. Great.
Inside of parentheses, multiply all by 100.
Yes. All of this needs to be multiplied by 100 so we can get like a better percentage. Are we done?
Return my difference.
return my difference. Awesome. So now what we can do is check to see. We're going to call this, what's our function name? Check enrollment rates by years. Check enrollment rates by years. Now, we're going to do UCSD. Do you want to do CSE or all data, Tyler?
CSE.
CSE data. Okay. What year do we want for year 1, Caesar?
2023.
2023. Great. Ella, what do we want for year 2? The data goes back to 2013 up to 2023.
2015.
2015. Let's do that. And then, Angel, what ethnicity should we look at?
Latino.
Latino, okay. So this is going to be Hispanic, Latino, Latina. Okay. Run that. Oh, UCSD data. Sorry about that. Run that. No. You need to print it out. The suspense. So, now what we're going to check to see is for all students of 2023 for Latin students in CSE compared to 2015's Latin students in CSE, was there an increase or a decrease in percentage? Let's run it. Ooh, there was a slight increase. From year 1 to year 2, year 1 had a slightly higher average than year 2 by around 1%. Okay, so there was like around a 1% increase in this information. Does that make sense? Awesome. Now we can do it for 2022 versus 2015. Oh, there was a decrease, right? Less than a percentage, less than 1/10%. So it's like around the same, right? Around the same enrollment rates for Latin students. Okay? Does that make sense of what we're doing? Of how we're doing all this? Okay? Awesome. So we basically asked the question, between 2 different years, what's the difference in enrollment numbers for a specific ethnicity at UCSD CSE? And now we got those numbers. We could also do it for, there was a 5% increase in Latin students across UCSD for all departments of 5.9%. Pretty wild, it's pretty good. What about the whole 10 years? 10-year difference. Nice. In the 10-year difference for all of UCSD, there was a 7% increase in Latin American students at the university. Well, does that make sense of how we can use this data processing to find out and answer questions that we're asking? Yes? Awesome! I don't think we have much time left. We have 3 minutes left, so we can't do much more. But, just as a little aside, get UC data is a little bit different. Sorry, question, yes?
Oh, yeah, it's not like really, but isn't this like more like data science related?
Yeah, this is like a lot of data science. Yeah. So we're using our computer science techniques of creating algorithms, creating functions, all of these things to analyze data. And that is data analysis. We're processing data. Processing it, reading it, understanding it, and asking questions and analyzing it. This is getting into data analysis territory. Yes, exactly right. Yeah. Any other questions? I love these questions. Any other question? No? Okay. I was going to get into this. We have very little time. I have 2 minutes left. But UC data is a bit different. UC data is actually a nested dictionary. So if we were to print UC CSE data, instead of a list of dictionaries, it is a dictionary of dictionaries. So there's no positional arguments, right? We don't say position 0, position 1 of UC data. We do position, like the key, UC Berkeley. So what we can do is UC CSE data at UC Berkeley. Run that. They have their own dictionary. And this is all for the year 2023. That's just the way that this data is presented in this CSV file. Okay. So in the year 2023, UC Berkeley had 639 international students, 199 unknown, 330 white, 1,706 Asian, 1 Native Hawaiian or Pacific Islander, 227 Hispanic Latino, Latina, American Indian 3, and African American 33. Okay. For UC Berkeley Computer Science Department for 2023. Okay. And what we can do is do similar sort of like data processing and data analysis to ask questions about this data. So if you'd like, as a nice little bonus for you all when you head home, I don't know if you want to do the bonus or just get started on PA6. I highly recommend you just get started on PA6, which is due on Wednesday. But what you could do is ask yourself a question of like the UC CSE data. Like for example, which UC has the highest representation for Native American students in the UC system? I don't know that question. I don't know the answer to that question, but you can find out using the techniques that you learned today. Okay? Any last questions? No? All right. Thank you so much, everybody, for joining me for this wonderful session of CSE 8A. See you all tomorrow. And thank you all for participating for today. That was really fun. Thank you for helping me create these functions. Thank you for asking that question, Tyler, about what we wanted to look and find out. We can start off next lecture tomorrow asking a different question for our UC data. Okay? So if you all have any questions lingering around in your mind, we can go ahead and program that at the beginning of next lecture. We can see how we do that. Okay?
Thank you.
Yeah, of course. Don't forget to do the evaluations, please. Evaluation of the course. Ciao, Hui. How did that go?
Cool, very awesome.
Yeah.
So sometimes actually I found Andrew, he's trying to ask more questions.
Yeah.
You may not notice it.
No, yeah, no. I noticed that he always